In today's episode, we are diving into Chapter 5 of the ISTQB Test Automation Engineer syllabus, Implementation and Development Strategies for Test Automation. So we will explore how to integrate test automation into your CI/CD pipeline, configuration management for testware, and what contract tests are and why they matter. As always, this podcast is fully AI generated by Notebook LM, simplifying complex topics and making our learning easier. So let's get started.
Welcome back to the deep dive. So let's start by looking at how test automation fits into something called CI/CD pipelines. Think of it like a high-tech assembly line for software.
Yeah, I like that analogy. Each stage of the pipeline represents a step in the development process, from building the software to testing it and then finally deploying it.
Right.
And automated tests are built right into these pipelines and act as quality gates at each stage. This ensures that each piece meets specific standards before moving on to the next step in the process.
So it's like having an inspection at every station on that assembly line, right? Making sure that everything is working correctly before we move on to the next stage.
Exactly. And catching those errors early on saves a ton of time and resources down the line. It's much easier to fix a small problem during component testing than it is to try and untangle a mess after the whole system has already been put together.
Right. Makes sense. So the syllabus gets into these specific test levels. It talks about configuration tests, component integration tests, system tests, and system integration tests.
Right.
Each one of these focuses on a different aspect.
Exactly. And it kind of builds upon itself, too. So you have component tests, for example. Those ensure that the individual units of code are functioning correctly in isolation. So that's kind of like the foundation.
Yeah. So you're making sure the individual parts work, right?
Yeah. Then you move to component integration tests, and that's checking how these individual components interact with each other.
Okay, so those are working together.
Then you have system testing, and that's looking at the whole system as a whole.
Right.
Ensuring it meets those specified requirements. And then finally, you have the system integration tests, which focus on how the system under test interacts with those external systems.
So with the component tests, you're making sure the individual parts work. With the system test, you're testing if the whole thing is running smoothly together.
Exactly.
Okay. The syllabus also emphasizes the importance of configuration management for what it calls testware. It's basically, managing all those different elements involved in testing. What does that mean?
Right. So it goes beyond just the test scripts themselves. You have to consider things like the specific settings of the test environment, the data used in testing, and even the various sets of tests that are organized for different purposes.
So you might be testing the same software on different operating systems or versions or even different devices, right?
Right, exactly.
How do you keep track of all of that?
You need a systematic approach to configuration management to handle all these variations. And this is where tools such as version control systems come into play.
Okay.
They help manage different versions of test scripts and environments, ensuring that consistency across the board. The syllabus even suggests using techniques like feature toggles. These allow developers to turn certain features on or off during testing, which is incredibly useful for isolating specific functionalities and testing them independently.
It sounds like using the right tools is absolutely crucial for keeping everything organized and running efficiently.
Absolutely. And you also have the concept of releasing the testware alongside the software itself.
Ooh.
This helps ensure compatibility with the latest versions and that everything's working together nicely.
Yeah, that's smart. It's like having a built-in quality control system that updates along with the software.
Exactly.
So speaking of systems, let's dive into a specific area. API infrastructure and dependencies.
Okay.
What's that all about?
So APIs, or application programming interfaces, are those messengers that allow different software systems to talk to each other. And testing software that relies on APIs, it brings its own unique challenges.
Okay.
Imagine you're building a house.
Okay.
You need to test not only the individual rooms, but also how they connect through hallways and staircases.
Right. So it's not just testing the software in isolation, but also how it interacts with other systems through these APIs.
Exactly. You need to understand how different APIs relate to each other and how data flow through them. And having good API documentation is like having a detailed blueprint of your house.
Right.
It guides testers on how to design effective automated tests.
And speaking of effective testing, the syllabus mentions something called contract testing, which focuses specifically on ensuring these different services can communicate seamlessly through APIs. Can you tell us more about that?
Yeah, so contract testing, it's all about setting clear expectations between the consumer of an API, think of it as someone requesting information,
Okay.
and the provider, which is the system providing that information. It's like establishing a contract that outlines how they should interact,
Oh,
ensuring both sides understand those terms of engagement.
so it's like agreeing on a common language before we even try to have a conversation.
Exactly. And there are two main approaches to this, consumer-driven and provider-driven contract testing.
Okay.
In a consumer-driven approach, the consumer dictates what they need from the API, and those expectations form the contract.
So that sounds pretty empowering for the consumer, right? It's like being able to say, this is what I need from you right from the get-go.
Yeah, exactly. It ensures that the API meets those specific requirements of the consumer. Then on the flip side, you have that provider-driven approach, and this is where the provider of the API actually takes the lead and defines that contract, essentially saying, this is what my API offers, and these are the rules you need to follow if you want to use it.
Right. So it's a little bit more of a traditional model
Mm-hmm.
where the provider sets the terms and conditions, right?
Exactly.
How do you decide which approach is the right one?
So choosing the right approach, it really depends on various factors like the complexity of the API, the relationship between the consumer and provider, and the development process itself. Sometimes, a combination of both approaches might be the best solution.
So it's not a one-size-fits-all situation.
Not at all. Requires, careful consideration and collaboration between teams.
And it sounds like that's what this whole thing is really about, right? This contract testing helps catch those pesky integration issues early on in the development process.
Exactly. So, remember those quality gates that we discussed earlier in the CI/CD pipelines?
Yeah.
Contract testing acts as another layer of protection. And remember that the world of software testing is constantly evolving, so stay curious, keep learning, and never stop exploring.
Great advice. Thanks for joining us on the deep dive, and we'll catch you next time for another exciting exploration.